Greetings and welcome to my channel. I am Mr. D, and today we will continue our discussion of the atom. We'll look at its structure, the number and types of subatomic particles, and how these relate to the type of atom and its properties. We know from the last episode that according to atomic theory, atoms are made of still smaller particles called subatomic particles. We've already met two of these subatomic particles, the positively charged proton and the negatively charged electron. Protons are found in the dense core in the center of the atom called the nucleus. It's the number of protons that determines which element is present. We represent the number of protons using the atomic number. Hydrogen's atomic number is 1, so all of its atoms have only one proton. Any atom that has 2 protons is helium. An element with atomic number 3 is lithium. An atom with 4 protons would be beryllium atoms. Boron atoms have 5 protons, so its atomic number would be 5, etc. Atoms are neutrally charged, so this means that the number of electrons will always equal the number of protons. It's the number and arrangement of electrons, most significantly the electrons at the outermost energy level, which determines the chemical properties of an element. To get an idea of the size and relationship between the two regions within the atom, imagine a hydrogen atom blown up to the size of a football stadium. The nucleus would be a marble at the center of the 50-yard line, and its electron would be a sand grain flying around the stadium's perimeter. So you can see that the atom is mostly empty space. There's a third subatomic particle we haven't discussed yet. It's neutrally charged, so it was given the name neutron. Neutrons are found in the nucleus with the protons. It's believed that neutrons help hold the nucleus together. Let's summarize some of the important information about subatomic particles. We have the proton, which is symbolized with a lowercase p, with a positive sign or plus sign in the superscript position. It is found in the nucleus, and it's got a 1 plus charge. Notice that it's a number and then the charge. The mass of a proton is given as 1 AMU, atomic mass unit. You can find the mass given in grams, but it's not a particularly useful number, so we're not going to bother with it. The electron, it's symbolized with a lowercase e and minus sign in the superscript position. And as we know, it is found in the electron cloud. Its charge is a 1 minus, so equal in magnitude to the charge in the proton, but opposite in charge. Its mass we give it as 0 AMUs. It does actually have a mass, but it's so small in comparison to the proton, it's negligible. The proton's mass is 1,830 times more than the mass of an electron. So it's just really not worth worrying about. It's just like if you were standing on a scale and you looked at your weight and a fly landed on you. You wouldn't bother to look at the scale to see how much your weight had changed, because the fly is not going to make any difference. It's going to be a negligible change. Neutron is N with a 0 in the superscript position, because remember, it's neutrally charged. Its location is in the nucleus. Its charge is a 0, and it has the same mass as a proton, 1 AMU, 1 atomic mass unit. Atoms of the same element have the same number of protons, consequently the same number of electrons. The number of neutrons, however, can vary. As a result, atoms of the same element won't necessarily have the same mass. You may remember that this is one of the ways that the modern atomic theory differs from Dalton's atomic theory. Atoms of the same element with different masses are called isotopes. Most naturally occurring elements exist as isotopes. When giving the name of a particular isotope, we include what is called the mass number in the name. For example, hydrogen 3. The mass number is the number of particles in the nucleus, the number of protons plus the number of neutrons. Please note this is not the same thing as the atomic mass of an element, which you will find listed on the periodic table. The atomic mass is a weighted average of all the isotopes of an element. We'll go into this in some detail at another time. Let's look at some examples. As we go through these examples, it would be helpful if you have a periodic table handy. So if you need to go find one, just go ahead and pause it at this point. The atomic number, which we find on the periodic table for an element, in this case hydrogen, is going to be 1. The mass number, which is in the name of the isotope, is 3. Hydrogen 3, the 3 being the mass number. Remember that the atomic number tells you the number of protons, so it's 1. The number of protons and number of electrons are always the same. That's because atoms are neutral. So since they're neutral, the number of protons and the number of electrons will have to equal. Positive charge will equal the negative charge. All right, and then to get the number of neutrons, you're going to take the mass number, which is the protons and neutrons, subtract from it the atomic number, which is the protons. So mass number minus atomic number, 3 minus 1, is 2. Our next example, nitrogen, the atomic number is going to be 7. The mass number, it's given in the name, it's 14. Protons, we know from the atomic number, which is going to be 7. In order to have a charge at 0, they have to have 7 negative charges, so 7 electrons. Okay, and then the mass number minus atomic number, 14 minus 7 is 7. For oxygen 18, atomic number, again looking at your periodic table, is going to be 8. The mass number given in the name, 18. Atomic number tells you the number of protons. Number of negative charges always equals the number of positive charges because atoms have no charge, so it's 8. Protons and neutrons are found in the nucleus. Subtract from it the number of protons, and it gives you the number of neutrons. Mass number minus atomic number. 18 minus 8 is going to be 10. Uranium-235, atomic number is 92. Mass number is going to be 235. Protons, 92. Electrons, 92. And to get the number of neutrons, mass number minus atomic number, 143. Okay, let's look at another table. This one's a little more complicated. This one, you have to think a little more. For hydrogen 3, our atomic number, periodic table, 2. You can also get it from the number of protons, because the protons, remember, is given by the atomic number. The mass number, given in the name, so it's 3. Electrons always equals the number of protons, so that's 2. And neutrons is mass number minus atomic number. 3 minus 2 is 1. Give you a second to see if you can figure out this next one. From the atomic number, we know that the element is carbon. And to name the isotope completely, we need to include the mass number, which in this case is 12. Number of protons is given by the atomic number, so that's 6. Electrons and protons are always equal, so that's 6. To get the number of neutrons, mass number minus atomic number, 12 minus 6 is 6. Okay, hopefully you've seen that since you have a number of protons is 50, that means you have an atomic number of 50. And if you look on your periodic table, you'll see that 50 is 10. And to get the mass number, take the number of protons plus the number of neutrons. 50 plus 68 is 118. So our mass number is going to be 118. The number of electrons equals the number of protons, 50. We don't have an atomic number or a number of protons this time, but we do have a number of electrons, which, remember we said, always equals the number of protons. The number of protons is given by the atomic number. So we can look on the periodic table, we'll find that this is iron, and the mass number is given on the table here, it's 56. Number of neutrons, mass number minus atomic number, so it's 30. Okay, the number of protons here is 11, so our atomic number is 11. So that means our element is sodium. The mass number is given on the table here, so it's sodium 23. Number of electrons always equals protons, so that's 11. Mass number minus atomic number gives you 12. Okay, last one here, the number of electrons is 19. So that means the number of protons is 19. Protons is given by the atomic number, so it's 19. If we look on the periodic table, find that 19 is potassium. To get our mass number, it's the protons plus neutrons, and that's going to be 40. So potassium 40. Finish out our table. 40 goes into the mass number. It can be cumbersome to use element and isotope names all the time, especially when writing a chemical equation, which is a shorthand way for representing what's taking place in a chemical reaction. So what we use are chemical symbols. Symbols are always printed. First letter is always capitalized, and if there's a second letter, it is always lowercase. In the description below this video, I've included links to a periodic table handout and a handout with the names and symbols of some elements. You would do well to memorize these selected symbols, as you should consider them walking around knowledge. It'll speed things along for you if you know them instead of having to look them up every time you need to use them. Well, that about does it for today. Thank you for watching my video. I hope you found it both informative and interesting. And if you did, please smash that like button below and consider subscribing and hitting the notification bell so you know when my next video comes out. When it does, please join me again. Until then, be good, be careful, and don't trust atoms. They make things up.